hope you are doing good. So today in this video, we will take a new binary search tree questions and which got recently asked in multiple interviews. So I thought let's take it up. So first we will understand the question here, and the given question is one root of the binary tree will be given, and we have to check whether the given binary tree is a binary search tree or not. This is what we have to check, and we are considering that BSTs cannot contain duplicate nodes. The given binary tree will not contain any duplicate nodes. That is what it is given. And the conditions for binary tree to be a binary search tree uh, are defined as here. So, for example, 5, right? 3, this is 8, this is 2, this is 4, and then left is 6, and this is 9. So this is a binary tree, right? Binary tree means the parent will have maximum 2 child, right? And then binary search tree, the left tree, right? Left subtree of the given binary tree. So this is the left subtree of this one, correct? So this must be the maximum of this left subtree must be less than the parent node value, right? And the minimum of this right subtree basically must be greater than, like, the minimum value of the right subtree must be greater than the node value, right? That is what it's given here. The left subtree of a node contains only nodes with keys less than the node's key, right? So this is the 5, correct? Here this is the 5, and all the keys in the left subtree must be less than the node's key, right? That is what it is saying, the first condition, this one. The second condition, it is saying right subtree of node contains only nodes with keys greater than the node's key, right? This right subtree, this is the right subtree for this node, correct? 5, 1, correct? This one. So all the keys inside this right subtree must be greater than the node's key, right? This one, this is 5. All the values are there in the right subtree are greater than the node's key, right? That is what I was telling, right? In other words, you can understand the left subtree, the maximum of left subtree, right? The maximum of left subtree must be less than the node's value, parent's node's value, and the minimum of the right subtree must be greater than the node's key, right? So if you go by this definition, these conditions, then what would be the basically maximum of this left subtree? Maximum is 4, right? 4 is less than 5, right? Condition is fulfilling. And the minimum of right subtree is 6, right? 6, 8, 9, the minimum is 6, and 6 is greater than 5, so this is a binary search tree, right? And both the left and right subtree must also be binary search trees, right? That is what it is saying. So I hope you understood how can we identify that the given binary tree is a binary search tree or not. So the first given example is here. We are given this binary tree, right? And so this is the left subtree. This one is less than the this one, correct? And this is fine. And then if we talk about then this node, correct, this one, and this is 5 is also greater than 3, so this is a binary search tree, right? So we are getting true, correct? So now take another example here, this one. So here this is a binary tree, given binary tree, and here this is the root node basically, correct? So now the minimum of this right subtree must be greater than this one, correct? So here if we take this subtree, then minimum of this one is 6, right? And 6 is greater than this one, so okay, fine. So now we are checking for this node, right? And this would be the subtree for this node, right? Right subtree. And here right subtree, the minimum of this one must be greater than this one, but this is not, right? 6 is not greater than 7, correct? So this is not a binary search tree. That is why we are getting false. Let's take another example here. So this is very general and very simple questions from the trees. right? But this is most common question which generally asked in the interviews, right? So, and if we take this example here, correct? So, for if we go for this one root, right, then this is the left subtree, and this would be the right subtree for this one, right? So, the maximum of this left subtree, right, max of left is 5, right, and minimum of right is 9, right? So this 9 is this 5. 5 is less than this, correct? That is fine. Now the minimum of right must be greater than the this node key, that is 10, right? So 10 is less than 9. This is not correct. So this is not a binary search tree. That is why we are getting false here. Correct. So I hope you got the questions. You understood how can we differentiate between binary tree and binary search tree. Correct. So now think about the solutions, the algorithms which can solve this problem. Right. Yeah. If you have the different solutions, algorithms, then whatever I will discuss, then please comment below the video and let us also know about your solutions, what you are thinking. So what I thought is there are multiple approaches for this one. So one approach is the first approach is what we can do. We can go for this root node, and then we find the left. Basically, we find what we can do. We find the min right, and we can find the max left, right? So maximum of from the left subtree, and we can find the minimum from the right subtree, right? And then we can compare like if this current, this is the current, you can say current arrow data must be greater than the maximum of left, right? Max left, correct? And this current arrow data is less than min right. Right? If it is not, if this condition is not, then we will return false, else we will go for left and then go for right as well. So this is what, this is the first approach, where what we will do, we will find the minimum left, minimum value from the left, from the right subtree, right, and maximum from the left subtree, and recursively we will do this process for each and every node, correct? So this is the first approach, right? So the second approach would be what I can do. I can traverse it this tree in order, right? So if we go by in order, right? So this is in order approach. In order. So here, if we traverse this, or if we take all the values in order manner, then the array would be 1, then 2, then 3, then 5 for this one, correct? And this array, this resultant array must be sorted. If it is sorted, it means this is a binary search tree. So let's take another example, this one also, right? So for this one, if we go for in order, right? So in that case, 2, then 7, then 6, then 9. I have already explained how can we traverse and uh, right in order manner, pre-order, post-order, or level order. Correct. I have already uploaded the video regarding this tree traversals, so you can watch those videos and you can get the idea. Correct. So this is the in order traversal. So 2, 7, 6. Now see here, 2. Then 7 is greater than 2, correct, fine, but 6 is not greater than 2, so this is causing the issue. And if this array is not sorted, right, this is not sorted, it means the in-order traversal is not giving the sorted array, so this is not a binary search tree. That is what we are getting, correct? So this is the second approach. Now coming to the third approach. Now third approach, so here a third approach would be basically, it is the modified version of this one only, right? Min and max. So where what we will check the value must be for example this one, right? So this node value must be in between the like maximum from the left and minimum from the right. If it is going outside this range, right? If the range for this node value, right? So the third approach is the node value, right? So this must be min right and max left. If it is in between these two range, then it is fine, else we will return false. If it is true, if it is in between this range, then we will go for the left subtree and we will go recursively for the right subtree. If it is going beyond this range, right? If it is going beyond this range, then what we will do, we will basically return false and say this is not a binary search tree, right? So this is the modified version of the above or the first one only. So I have explained you these multiple approaches here. So let's go through the code for each and every approach, whatever we have discussed. So this is the code for first approach, whatever we have discussed, where we will find the minimum value and the maximum value, right? Minimum value we are finding from the right subtree, right? This one is the minimum value from right subtree, and maximum value from the left subtree, right? That is what I have told you, correct? And then we are comparing this value with the root arrow data. See here, if this is this maximum value is greater than the root arrow data, right? It means the left subtree node is having the greater value than the parent one, right? It means this is not a fulfilling. This is not fulfilling the condition of the binary search tree, and we are returning directly false from here itself, correct? And same is here. If the minimum value from the right subtree, right, is less than the root arrow data. So, for example, this case, right? So this is 5, and here this right side, if we are having 3, right, minimum value, it means this is not fulfilling the binary search tree conditions, where the right must be greater than the parent node and left must be less than from the parent node, correct? So we will return false. Else, if these two conditions are fulfilling, right, means the maximum of the left subtree is less than the parent one, and the minimum of the right subtree is greater than the parent node value, right? In that case, what we will do, we will go and check recursively for the left binary search tree and the we will go for the right node and left node both recursively, right? That is what we are doing here. And for left and this min and max, I have added the helper functions to calculate. So here this is the code, right? For this is the code for max, calculating the max value, right? We will give the node here, root node, and we will find here. So and this is for the finding the minimum value, and this is for the finding the maximum value, right? It is very simple code, right? You have to root value, then max value for the left max, right max you will get, and then you compare here, right, and update the this one, maximum of the root value and maximum of left max and right max. That is what we are comparing here, correct? So this is the first approach. Now coming to the second approach. So this is the second approach, where we have discussed like we will take a in-order traversal, right? So that is what we are doing here. So here we are basically like traversing the tree in order manner, and we are taking these outputs into the vector, right? So this is our code for in-order traversal, right? Where we will go first left, and then we will put that node value into the resultant vector, and then we will go to the right, right? So for example 1 sorry here 4 3 and this is 5. So what we will do here, we will first, right, I have told you, we will go left here, right, and then this is null, so we will come back and then we will print 3, correct? And then from here we will return and we will print 4, right? And from here we will go right and we will go left, come back, and we will print the 5, and we will come back, go right, come back, and then we will return from here itself. So 3 4 5, right? This is what we will get from the in-order traversal for this given tree, correct? So let me clear this out. So now here we are putting the in-order traversal value in the resultant array, right? And here this is the code for checking if the array is sorted or not. That is what we are checking here. We are doing here, right? So this given array, like the in-order traversal array, is output is in sorted manner. It means it is a binary search tree. If it is not in a sorted manner, then we can say this is not a binary search tree. That is what I have explained you, correct? So this is the second approach. Now what we will do, whatever we discussed in the first approach, we will modify that in a simpler version in the third approach. That is what I have explained you. So this is the third approach. So here what I am doing, so like whatever we discussed, right? If the what we will do, we will check for the left binary search tree, and the maximum value from the left must be less than the parent node value, and the minimum of the right must be greater than the parent node value. So that is what we are doing here. So in modified version, what we were checking that the node value, this value must be in range, right? This value must be in range. It means the maximum of left, right, must be less than, and then this node value, right, and it must be less than the minimum of right. So it is in range, right? If it is not in range, then what we will say, we will return false. This is not a binary search tree. That is what we are doing here, basically, right? We have modified our initial approach, first one, correct? So here what I have added, I am passing minimum and maximum, right? Min is int min and int max is the maximum value, right? In this helper function, it's PST utility function, right? And here I am checking node arrow data must be if it is less than the minimum value, right? And if it is greater than the maximum value, it means it is out of the range. And in this case, what we will return the false, correct? So that is what we are checking here. Now if it is not, if it is in the range, right, this is a reverse condition basically, right? In that case, then what we will check, we will go for the left tree for this one, and we will go recursively for the right one. So right, so when we are going left, it means this would be your maximum, right? So this is our given binary tree, for example, and if we are checking for the left one, it means the parent would be our maximum. So what we will do, we will update our maximum value here, right? That is what we are doing here in this first call. We are going left, node arrow left, right? So node arrow left, then what we are checking, we are keeping the min as it is. We are not modifying the minimum value, right? But we are updating the maximum value here, correct? Why? Because we are going left side. When we go left side, then in binary search tree, the condition is the parent node would be greater than from the left. So this would be our maximum value. That is what that is why we are updating this maximum value here. And when we are going right, see here, when we are going right side, this side, then we are updating the minimum value. Why? Because when we go right, then maximum could be anything, but the minimum value would be the parent node value, because the right subtree, like the right node must be greater than the parent node. That is what the condition says for the binary search tree. So that is why we are updating the minimum value here. See, this is the minimum value, right? We are passing minimum and maximum. Maximum we are not modifying it, we are keeping it as it is, but we are updating the minimum value, right, for the when we go for the right side. And we are performing an AND operation here, right? So both must be true, then only we say the tree is binary search tree, right? If any one of these two calls is returning false, it means false, means the given binary tree is not a binary search tree. I hope you are getting it. It's very simple, right? So this is the main thing here, where we are updating the maximum, and here we are updating the minimum, right? And you can understand this in this way. Like if we go left side, right, then the parent would be or greater. That is why we are updating the maximum value. And when we go right side, then our parent value is the less than the right one. That is why we are updating the minimum value when we go right side, right? So I hope you are getting this one. you understood all these three approaches, right? And this is very common question, but you must know these three approaches or other than these approaches as well, right? Because this is recently asked in multiple interviews, and this is very general and very common questions in binary trees, right? So yeah, that's all for today. See you next time. Till then, keep learning and keep exploring.